Thank you, Omar.
Thanks. Hi, everyone. I know it's late. I'm going to try to keep it as simple as possible so we can all go to the party. So, as everyone here in this room, as developers, we get asked by our non-developer friends every time, a lot, I have this interesting idea for an app. I have this $1 million idea for an app, and they see Steve Jobs in their minds, and they want to be billionaires, and they come and talk to us. So I had one of my friends one time tell me, hey, I have this very interesting idea for an app that shows you memes, funny memes, or you can laugh and say, hey, have you looked at 9gags, for example? And I have this idea for a dating app. Have you looked at Tinder? And even one time, one of my friends just came to me and told me, I have this very interesting idea that will help you find a nearby barbershop. I told him, yeah, have you looked at Google Maps, and are you sure you're targeting the right audience? So, an app for this, an app for that. They always come to us and they ask us for app ideas. And I thought with myself, yeah, I am a developer. How come I don't come with my $1 million idea? I can do this. I can build one. So I started searching, and I searched a lot until I found my $1 million idea. The idea was to build an app to enable users to take a photo and instantaneously put it out there on the line. Anyone knows this app? Let's build Exchangeagram. So I was sure that my application will be a huge success, especially that it's very unique. As a developer, I jumped into my Xcode and I started working. And before finishing the application for a few days, I discovered that there's this small company called Facebook that they replicated my application idea and created a clone called Instagram. They even stole the idea before me releasing the application. But the problem was that I built so much into the application. I mean, look how much I added into the application. There was code for in-app routing, caching, networking, image editing, video editing. It took me a lot of time to build. I never gave up. I came up with another $1 million idea, which is LickLock. So this is my new, very original idea that I want to build. But this time, I want to see if I can share any of my previous code in Exchangeagram and add it into LickLock. So when the time comes and someone decides to steal my original idea, I can come with another one and come to market quickly. And the answer to do that was by building frameworks. So today, I will keep it simple. I will just share some tips and ideas that might help you to design a very nice Swift frameworks. First, let me introduce myself. My name is Omar Albeik. I'm originally from Aleppo in Syria. I live in Amsterdam, and I work for a company called Backbase. We do banking SDKs to enable banks to bring really delightful experiences to users. So if you have a nice application for your bank and use it on a daily basis, chances are very high that they are using our software. I enjoy building tools and frameworks in Swift. In my free time, I practice Arabic calligraphy. And I'm a huge fan of espresso. I think I'm in the right place. So let's start with why and when. Well, obviously, the reason we create frameworks is to increase code reusability and to separate the concerns and improve testing. So we have this one unit that we tested really well, and we start adding it in multiple places. But we can also create Swift frameworks so we wrap our C or Objective-C code in a nice Swift API. We can create frameworks also if we're building multiple apps, so that can serve as the foundation layer we build all of our applications on top of. An example would be networking code. When do we build a framework? Well, if we have a lot of duplicated code, we start to see this code is being duplicated in many places. Basically, if the code appears more than once, it probably belongs to a framework. And if you're building an application with extension targets, you need to share code between targets. This is also a good example. So let's dive in. Let's see some tips about building Swift frameworks. The first one is to be elegant when designing Swift frameworks. Read the Swift API design guidelines. I think this is crucial not only for building frameworks, but also for writing Swift code. To summarize, I will just mention 5 points. The first one is clarity at the point of use is very important. So you're going to write your code in one place, use it in dozens of places, 100 places. And if your framework is going to be distributed for other developers, it might be used for 1,000 times. When you read the code, it should be clear, it should be precise, and it should read in a way that does not leave any room for misunderstanding. And they say in the Swift design guidelines, if you're having trouble describing your API functionality in a simple terms, you may have designed the wrong API. So keep it clear. Second is, please don't use prefixes in Swift-only frameworks. This is not Objective-C. Prefixes are not needed anymore. They're ugly. They don't read nice. And the Swift module system allows to differentiate between objects in different modules by prepending the module name. Third is to prefer structs over classes. Now, structs are value types. Classes are reference types. By using classes, sometimes we bring some side effects that comes due to the nature of classes. And also by using struct, you get default initializers for free. We've all seen how Apple gave us a great example when starting with Swift UI. They just defined everything into structs instead of classes. Although classes makes a lot of sense in some places, so don't fight the system. If you're working with UIKit, it makes sense. They are classes because they need to be shared. Just don't fight the system. 4 is to prefer composition over inheritance. So next time you want to create a base class, before doing so, think, why am I creating this base class or base object to inherit from? Is it because they share a lot of, is it because they need to share features of or data from the base class, or is it because only they want to share some features? If so, consider creating protocols and compose them into this object. And finally, make good use of generic types. So who knows this guy? Okay, his name is Krusty. Apple had one of the best talks ever in 2015 in WWDC that created a lot of buzz. So what they were talking about is to use protocols everywhere. And people misunderstood them. So they started to create protocols again for, like, sometimes it doesn't need to create a protocol. So last year they discussed in WWDC, don't overuse protocol, guys. Just before creating a new protocol, think if you can solve the problem using a generic type. So protocols are nice, but don't overuse them. To learn more about these topics, there's these 2 talks from WWDC I highly recommend. The second thing is to lint your code while you're writing. A tool like SwiftLint will lint your code and at the same time writing it, so you will write an elegant code. Now let's talk about some modern Swift features you can use. It will empower your frameworks and make them better. The first one is property wrappers. So they are these things that you see in Swift UI, like observed object, state, object binding, and others. The whole idea is very simple. So basically, they intercept setting and getting values for a property. So as an example, you can have this trimmed property wrapper. All it will do is when you set a text, when you set a string into a property, it will trim the leading and trailing sides of the string. So if you do something like this and print it, it will print hello world trimmed. Another example is this transformed property wrapper that will do a ICU transformation for a string. So if you define a property Shanghai and you write Shanghai in Chinese, print it, it will print Shanghai in English characters. This one is interesting to compare 2 values case insensitively. So you create this property wrapper, you conform to the equatable protocol, and instead of comparing these 2 values, you lowercase them and then you compare them. So if you have an account that has a name property that is case insensitive, you create two objects. One of them is with lowercase characters and one of them with uppercase characters, and you compare the two objects. You see they are the same, but if you compare the name property on both of them, you'll see it's not the same. They are different characters. If you're interested more, there's this really nice post by Matt in NS Hipster about Swift property wrappers that I highly recommend. Second is function builders. Now, function builders is what enables Swift UI elegant declarative syntax. If you're designing a domain-specific language framework, this is a game changer. Some examples is, of course, the well-known Swift UI. This one, I think they demoed also in WWDC. It enables you to write HTML in a Swifty way. And there's this example that enables you to write NS attributed strings in a very elegant way. The third one is KeyPaths. Now, KeyPaths is a very interesting feature of Swift. It enables you to store an uninvoked reference to a property. It's a fancy way of saying, of referring to the property itself rather than the property's value. So if you have this user, and this is how you get the name KeyPath and the age KeyPath, and then you can subscript the object with the KeyPath to get the value. A year ago, I read this blog post by Paul Hudson about how Swift KeyPaths enable us to write more natural code. And I thought this will be a really nice addition if we can store codable objects into user defaults using KeyPaths. So I went ahead and I created this small, tiny open source project. It's called User Default Store. So basically what it does, it enables you to take any codable object and store it into user defaults and work with it like it's an actual database. So it all revolves over this identifiable protocol. This was created before Swift UI added this identifiable object. It's very simple. It has just an associated type and a writable keypath that enables you to read and write a property at the same time, a value for property at the same time. So how do we use it? If we have this user object that's codable, first we conform to the identifiable protocol. Second, we tell the framework what is the type, what is the property that you promise it will be unique for the same object, for different objects of the same type. It could be UUID, it could be double, it could be string, it could be a dictionary, it could be an array, it could be anything you want. It could be any hashable object. And this is how you create a user default store using a generic type. You tell me what type you want to store, and you give it a unique identifier. So if you have these two objects and you want to store them, this is how you save them. This is how you save an array of objects. And this is the interesting part that uses KeyPaths. You see these two lines, they have the same function, but it's the same function one time triggered with an integer and the next time triggered with a string. And this is because of how powerful KeyPaths can get in Swift. You can get all objects. You can check if a store has an object. You can iterate over objects. You can delete an object. Again, it takes different argument type based on the object you're storing. And if you look at the implementation for the save function, all it takes a codable object, a codable and an identifiable object, and then it calls this key for object function, and all it does, it just takes the unique identifier for the store and append the value of the key path of the ID key. It's the same for getting the object. Fourth is result type. Now, results was introduced in Swift 5. It enables a very natural way of defining and dealing with operations that ends in one of two scenarios, either success or failure. And this is how we use them. So if you want to read the contents of a file and save it in a string, this operation can have one of two scenarios. It's either success or failure. This is how it works really well with switch cases. You can use it also for networking calls. It looks really, really nice, and it works great. The fifth one is not necessarily new in Swift 5, but it's very powerful. Enums are very powerful in Swift. They are first-class citizens. They can have initializers. They can be extended. They can conform to protocols. They can take a generic types. They can have associated values. So you can do everything that you can do with normal structs with enums. And this can be very powerful. So if you have this enum that represents a stock trade, either you buy or sell a stock with an amount, you can see how you can pass values to this enum, and you can do the trade by switching over them. And you see how Swift switch statement is very nice because it does not ask you to write a default statement if you fulfill all of the cases. So there's a library on GitHub called Moya. Who here knows about Moya? Yeah, it's pretty famous, and it utilizes enums to the maximum. So it's an abstraction layer on top of Alamofier. It uses enums where you can define your targets and you can define your endpoints and then switch over them. If you haven't looked at it, I highly recommend it. It's very nice. Give it a look. Now, these are some of the features available in Swift that enables you to write really good frameworks. And they are all available in Swift 5 Pro. That's $4.99 per month, and it has a family subscription. No, I'm just kidding. It's available in Swift, but who knows, Apple might surprise us in the near future. Now let's talk about another topic, which is wrappers. So wrapper is not a language feature, but it's a way of organizing your code, especially when it has a lot of extensions. And the way you use it, you can wrap extensions. So we all use extensions in our applications, so code like this is very familiar. We're extending date to have a property that will tell you if the date is within today or not. Now, the problem with this code is it might collide with other extensions in other frameworks. It doesn't play nice with other frameworks. Instead of doing this, create a new struct, call it extension wrapper, that has only an initializer to set this type. It takes a generic type. And then create a protocol called extension compatible that has an associated type and two properties. One of them is normal, one of them is static. And have the default implementation for this protocol. This, yes, so this ext can be anything. For example, in Backbase, we call it BB, stands for Backbase. It can be based on your framework. And the way you use it, first, you conform to this compatible protocol from the type you want to extend. And then instead of extending the type, you extend the wrapper where the base is the type you want to extend. And you can use it like this. So the object.ext. And you get everything that you extended for your types. So you see, this is very powerful because it acts like this magic door for your for the developers to see what options are available specifically in your framework without mixing it with other frameworks. And it makes a lot of sense. And one interesting idea you can use it. You can use the wrapper in is wrapping third-party dependencies. So if you have a code like this, and all it does is sets an image for an image view from a URL, and you're using Kingfisher to do so, what happens if in future you decided to change Kingfisher into something like STW image? So if you wrap your third-party dependency using your extensions wrapper, you can take this dependency, introduce a new one without creating any breaking changes for your framework. So I think this is really powerful. It enables you to have this abstraction layer on top of third-party dependencies. So in future, if you decided to write the code yourself or just to change the framework, you don't introduce any breaking changes. So it also helps us for our implementation details not to leak out of our framework. Fourth is don't overshare. Especially when designing a framework, pay good attention to access control. You don't want everything to be public. So as a rule of thumb, start always with a private. And this is, again, applicable not only for frameworks, but for any time you're writing Swift code. Just because you're in a framework does not mean that everything should be accessible within the scope of the framework. Some files need, some objects need to be private and not accessible from other files in the same framework. If your object needs not, it's not helping to have it private, make it internal. That will be available within your framework. If you need something more, make it public so you can access it from other modules. And if you have classes that you want developers to be able to override the implementation for them, make them finally open. Second is to avoid creating global objects. Now, you should prefer methods and properties to free functions and values in your framework. So if you have a code like this, you see these objects are floating out of nowhere, like they don't have any parent, which is common in Objective-C, but it's not a good practice in Swift. So instead of that, you can create a struct. You can make the initializer private so developers will not be able to create a new instance of this struct, and then you add all your functions and properties as static types to this config struct. Third is to use final for classes not intended to be subclassed. So if you have a specific UI element that you don't want to, the developers to be able to override the implementation for it, make it final, and they will be able to use it. It's public, but they will not be able to subclass this object. The fourth is to design platform agnostically. So if you're building a framework that has this extension, you see there's this import UI kit at the header of the file. Now, this is problematic because right now you're developing for iOS, but in the near future, you might be developing for Mac. So it doesn't hurt to add this can import UI kit, if can import. This is an awesome Swift feature. Make good use of it. So here's some real-life example from my previous company. I was working in Istanbul. So we had close to 100 applications. We had, among these applications, we had like around 1 billion users. So it was a lot of users. And we needed to find a way to initialize our applications in the app delegate, but not to have our app delegate 500 lines of code. So there was a lot of SDKs, especially with monetizing, analytics. There were Facebook, Firebase, Google, Adjust, many others. So to solve this, we created a protocol called Splash Showing that has all the requirements for showing a splash screen for the first launch of the application and have a nice spinning indicator while we do all the initializing. And we extended UI application to conform to this, to our extension compatible protocol. And we created this extension that takes a view controller that's splash showing type and takes launching arguments from the app delegate. It does the initializing, it shows the animation, and when it's done, it returns the control back to the app delegate. And it was working well. It served out for a long time until we got a new requirement to have a custom keyboard in one of our applications. Now, the problem we had is we made the assumption that every time the users will initialize the application, they will have this splash view controller. We didn't think that if we have another keyboard, for example, keyboard extension target, you might launch the application but not see the splash view controller at all. So learn from our mistake. Don't force your application to be used in a very specific way if you don't have to. Finally, design architecture agnostically. So don't make the assumption that implementers are using MVC, MVVM, Viper. Don't make the assumption that they are using reactive unless there's a very specific feature that you want them to do so. Instead of that, think, how can I design a tool that will enable developers to be successful and build applications without knowing about what platform, what architecture are they going to use. Now, to talk a little bit about architecture, every framework has a very specific need. So I will compare 3 frameworks that I've been working on for the last 3 years, and each one is very different from the other. The first one is an open source project on GitHub. It's an extension library. So the goal here is not to have a framework that you can use it as a dependency in your projects. Also, you can do so. The goal is more to have an extension library as a reference point where you can come. It's like Wikipedia. You can come, copy what you want to use, and use it as a single unit. So we don't allow cross-dependency between extensions. If you have an extension A and extension B, you cannot have extension B rely on extension A. Because of that, we had a lot of duplicated code, and it's OK. We allow duplicated code in Swift or Swift. It's more like a reference point than a framework. For the other framework that I built, that was the framework I told you about where we have 100 applications. It's not open source, unfortunately. The idea was to enable developers to come up with applications instead of spending months. Just develop an application, ship it to market in a few weeks. It had a very structured way of doing things because, again, the goal here was just to release applications quickly. We have all this application shared also the same backend they were talking to. It's built to be used as a complete package. You just use it as is, all of it. It has a focus on in-app purchase and ads because this is where the company was making money from. It had a heavy usage of singletons because most of this monetizing SDKs, Objective-C SDK, use singletons. It had some fixed UI components that, again, you have to use it with the minimal customization. Now, what we do right now in Backbase is we develop SDKs, and they are used. We have a core SDK, and we have a widget collection. So basically, more than 40 frameworks that they all share this core SDK as a dependency. The idea here is that developers will use these components or widgets and mix and match them. So we don't know if the developer will be using ABC or just AC or just AB. They have only one dependency between them. Because we don't know if all dependencies are available or not, in the runtime, we rely on our custom implementation for pub/sub communication style using notifications. And we care about security because this is money, this is banks. And we only deliver business logic. So we're not forcing any specific UI. You won't see any UI kit in any of our widgets. So the key, the takeaway I want you to know from here, I want to talk about from here, is to use many small, well-focused frameworks instead of having this giant framework to build your applications. If you know about backend development, you might hear about the microservice mindset, the microservice way of doing things. It's the whole idea. Instead of having a giant, huge server, you have multiple servers that each one of them does a very specific job, and it does it really well. Try to make frameworks as independent as possible and as well-focused as possible. 6 is to document like a pro. So in Xcode, you can have this. You can use this shortcut, and it will generate a markup documentation for any unit. There's this book that I highly recommend by Arika Sadon. It explains how this markup language works and how can you use it. It's very similar to Markdown, by the way. And once you have everything documented, you can use Jazzy. It's an awesome tool that will create a very professional website, a documentation website for your code. It's something similar to what Apple has. Now let's talk about distributing Swift frameworks. The easiest thing you can do is you can just start creating a new target in your application. I know this is not technically a framework, it's just a different target, but it will help to write the code in a separated manner. So you just focus on the scope you're writing in. So in future, if you decided to separate this into a framework, it will be really easy to do so. You can use also Swift Package Manager. I'm not going to go into details. We had enough of Swift Package Manager today. It's very easy to do it from the command line. You just create a new folder. You call Swift Package init, and Swift Package generate Xcode. It will generate you an Xcode project where you can start adding your Swift files. And by default, it creates a framework, a cross-platform framework, so you can have it on all these frameworks, on all these platforms. There's this really nice talks, if you're interested in Swift Package Manager, that you can refer to from WWDC. You can use CocoaPods. Now, because Swift Package Manager is fairly new and it's not yet ready, there's some missing features from it. CocoaPods is handy. Again, you can use the command line to create a new framework. It will ask you some questions, whether you want to develop for iOS or Mac, what language you want to use. Of course, it's Swift. Do you like to include a demo application? Would you like to use any testing frameworks? And it creates this Xcode project where you can start adding your Swift files to it. Finally, is to use some sort of versioning system. So now, semantic versioning is the industry standard, but in some scenarios, in some frameworks, it might make sense not to use semantic versionings, to use something like cal versioning, like what Ubuntu is doing, for example. So to be committed to releases based on their calendar times. I didn't find a suitable emoji for releasing, so I chose this unicorn. Semantic versioning is very simple. You have a major, a minor, and a patch release. The takeaway here is to use semantic versioning or any other versioning system, but to be committed to it. So to summarize, when you design Swift frameworks, be elegant and use a linting tool to lint your code while you're writing. Property wrappers, result types, KeyPaths, Enums, and more are really powerful features of Swift. Make good use of them. Use wrapper for your utilities or extensions framework. They can get really powerful, especially if you want to wrap third-party code. Don't overshare when designing a framework. Don't leak your implementation details. Each framework is very unique. It has its own needs, style, and architecture. Always document your code while writing. And use a versioning system. I will be sharing these slides and many other useful resources on my Twitter. Thank you very much.